So in the last video, we talked about the independence of two events and the resulting multiplication rule that allows us to calculate the probability that both events occur for two independent events. In this video, we're going to talk about some addition rules. And those rules allow us to calculate the probabilities that one event or the other occurs. So in the last video, we were talking about intersections of events. Remember, that means and. So both events occur. Here we're talking about the union of events, meaning one or the other, or possibly both events occur. So that's associated with an or statement. We've already talked a little bit about this in that we mentioned mutually exclusive events. We also called them disjoint events. And we said that if two events were disjoint, then the probability of their union occurring, meaning the probability that one event or the other occurs, is simply the sum of the probabilities of their individual events, the probabilities of the individual events occurring. So again, if the events are mutually exclusive from one another, to get the probability that one or the other or both events occur, you just add the two individual probabilities together. But what happens if the events aren't disjoint, meaning they are not mutually exclusive from one another? If we represent that with a Venn diagram, then that means the two events are going to overlap to some extent. In this case, we need to make an adjustment to our original formula. Notice, we're still saying that we're calculating the probability that the two events occur, the probability of event A or event B occurs. And we are still adding the two individual probabilities together. However, the adjustment occurs here at the end of the statement where it says that we have to subtract the probability that event A and event B occurs, which in our Venn diagram, of course, is this area here where the two overlap. Now let's think a little bit about why it is that we need to subtract the probability of the intersection of our two events. I'm going to go back to the last slide for a second. Before, when the events were disjoint and there was no overlap, of course it would make sense that we would just add the two probabilities together because this represents part of the overall event, the union of the events that we're interested in, and this area represents the other part. But here on this slide, because the two events overlap each other, if we didn't subtract the probability of their union occurring, the probability of their intersection occurring, then we would double count that portion of our Venn diagram. So let's use the Venn diagram and take a look at what I mean. Here in the formula we say, all right, we want to add the probability of event A, which of course is this entire area here. But we also say that we want to add the area of event B, which is this area right here. And you can notice from my very sloppy shading that if we just add those two probabilities together, then in this region here where the intersection occurs, we have double counted that region. We included it in the probability of event A and the probability of event B. So the reason for us subtracting the intersection in this formula is because of that double counting issue. We don't want to count that region twice, so that means we need to subtract it from our overall probability. So let's take a look at an example. Here I've drawn a Venn diagram of some event A and some event B. And let's just take a look at what this Venn diagram is telling us. It looks like the probability that event A and event B occurring, again that's the intersection, that's where the two events overlap, and the probability of that is 0.1. The probability of event A occurring is the sum of the two areas that are within the region for event A, and that's 1/2 plus 0.1. So the probability of event A occurring is 0.6. And the probability of event B occurring, very similarly, is the sum of the two regions that are within the event B area. So that's 0.2 and 0.1. So the probability of event B occurring is 0.3. So now we can figure out what the probability of event A or event B occurring is, just by using the formula that we saw on the last slide. Remember, that's the probability of event A, which we just said was 0.6, plus the probability of event B, which we said was 0.3, minus the probability of their intersection, which is 0.1. And so if we add all those together, we get a probability of 0.8. And that, again, is the probability that event A or event B occurs. Now, if you look back up at our Venn diagram, you might be thinking, well, duh, that's pretty obvious. Because if you add these three values together, 0.1 plus, or 0.5 plus 0.1 plus 0.2 gives you 0.8. Now, if you're given a problem with a Venn diagram like this, it's probably pretty easy to figure out what the the union is. But you won't always be given this Venn diagram to go off of to get your solution. So that's why it is still important to know what this formula is and how to use it. If you can somehow take the situation that you're given and represent it with a Venn diagram, you might be able to figure out what the probability of the union is just by summing these numbers together. But you might not necessarily be given the Venn diagram from the start. You might have to create that yourself.